In the last video, we looked at how to use the cosine rule to work out a length in a non-right angle triangle, or to work out an angle if you're given all three lengths in a non-right angle triangle. We're going to extend this by looking at something called the sine rule. And the sine rule again applies to non-right angle triangles, but you only use the sine rule when you can't use or cannot apply the cosine rule. So to use the sine rule, you're going to be looking for something called length angle pairs, which I'm going to explain in a second. It's a fairly straightforward concept to get to grips with. So we're going to look at the sine rule to calculate lengths first of all. And like with the cosine rule, the sine rule is just a formula that you're going to be given in the formula sheet, which again you do not need to memorize. And we're going to look at how this formula, A over sine A equals B over sine B, can be used to calculate lengths in a non-right angle triangle. In this triangle, we've got two angles, 40 degrees, 70 degrees. We're given one length, the length of P to Q, and we're asked to work out the length of Q to R, which I've called X. The first thing to note is that you can't use the cosine rule to calculate X because we've only been given one length. And with the cosine rule, you need to be given two lengths and the angle in between those two lengths. So we know we can't use the cosine rule, so we need to use the sine rule. Now, this whole concept of length angle pairs basically refers to an angle and the length which is opposite the angle. So if you look at the 40-degree angle, that 40-degree angle looks at the length x, and that's what we call a length angle pair. It's basically the angle and the length which is directly opposite that angle. Now we also have another length angle pair in this diagram because we can see that the 70 degrees is directly opposite the 10 meters. So the 10 meters and the 70 degrees are what we call another length angle pair. So the length angle pairs in this diagram are the 40 degrees and the x, and then the 70-degree angle and the 10 meters, which is directly opposite it. When we've identified the length angle pairs, we can then look at this sine rule formula and see what it exactly means. What this formula basically tells you is that if you are using the angles, or the sine of the angles, then the length angle pairs are basically equal to each other if we use the sine. So A over sine A is one length angle pair, and B over sine B is another length angle pair, and those two are going to be equal. That's what the sine rule is telling you. So if we look at the length angle pairs in the diagram, and we're going to apply the length angle pairs to this formula, we can write A over sine A. Well, A will be the x, so the x and the 40 degrees are one length angle pair. So we can write x over sine 40, that's one of your length angle pairs, is equal to the blue length angle pair, which is the 10 meters and the 70 degrees. So we can write 10 over sine 70. And that's the application of the sine rule. So all we've done is we've created this little formula that we need to solve in order to get the value for x. So that's the application of the sine rule. We don't need to worry about this formula anymore. So to solve this simple equation, to get the x on its own, we are going to bring this divide by sine 40 over the equal sign to the right. So we're going to be left with x equals 10 over sine 70 times sine 40. Remember, the angles go in a bracket. So what I'm going to do is I'm going to type this into the calculator in one go. So I've got 10 over sine 70 So I'm going to press the fraction button. 10, go underneath, sine 70, close brackets. Go to the right, times sine 40. Again, the angle goes in a bracket. Press the equals button, you get 6.840 or 6.84 to 3 significant figures. So the length rather is going to be 6.84 and the units will be meters, and that is the value for x, or the value for q to r, which is what the question actually wanted to calculate. The sine rule can also be used to calculate an angle in a non-right angle triangle. We always, as I mentioned, check to see whether we can use the cosine rule to calculate an angle. To calculate an angle using the cosine rule, you need to be given all three lengths in the triangle. In this case, we're not given all three lengths. Because we're not given all three lengths, we have to use the sine rule. So you always check to see whether you can use the cosine rule first, and if you can't use the cosine rule, you have to use the sine rule. The sine rule for calculating an angle, it's very similar to the formula above, but all we do is we turn everything over. So we put the sines on top and we put the little lengths a and b at the bottom of the fraction. So effectively, all we've done is we've flipped the equation that we have above. It just makes the algebra a little bit easier. So when you're trying to work out an angle using the sine rule, the sines have to go on top of each of those fractions. We do what we did before. We identify the length angle pairs. So you can see that the x degrees is opposite the 8 meters. So that is one of your length angle pairs. The other length angle pair will be the 80 degrees and the 12 meters. The 80 degrees is directly opposite the 12 meters, so that's what we call a length angle pair. So we put the length angle pairs into the sine formula. So remember, we have the angles on top, so if we look at the red length angle pair, we've got sine A over little a, so it'll be sine x over 8 meters as the first part of our formula. So we'll have sine x over 8. That's one of our length angle pairs. And that's going to be equal to the other length angle pair, which is the 80 degrees and the 12 meters. So on the right, we're going to have sine 80 over 12. And that's the application of the sine rule. The next step is just to use a little bit of algebra to get the value for sine x. So we want to get the sine x on its own. So all we're going to do, we're going to bring this divide by 8 over to the right, so it becomes a multiply by 8. And we write sine x, because that's what's going to be left on the left-hand side, equals sine 80 over 12 times 8. And remember, what we're trying to calculate now is not x. When we type sine 80 over 12 times 8 into the calculator, we're going to get the value for sine x. So if we bring up the calculator and we clear the screen, so I'm going to press the fraction button, sine 80 over 12 times 8. That gives me a value of 0.6565. Now remember, that is the value for sine x. So sine x will be 0.6565. Now I'm going to keep that to 4 decimal places, but remember, we can use the answer button to work out the inverse sine. So if I press shift sine, answer, and then close bracket, I get the value for x as being 41.0 degrees. And that is the angle that I wanted to work out. So x is going to be 41.0 degrees. So remember, when you work out the right-hand side of this equation, you're not getting the value for x. You're getting the value for sine x. You just need to remember to take the inverse sine of that value to get the final angle, which is the answer that you're actually looking for. And that's how you apply the sine rule to solving problems. So like with the cosine rule, you can use the sine rule to calculate lengths, and you can use the sine rule to calculate angles. To reiterate a simple point, you only use the sine rule when you can't use the cosine rule. So if you're looking at an exam question, check to see if you can use the cosine rule first. If you can use the cosine rule, use it. Otherwise, just use the sine rule.